All right. And there's Stefan. How you doing, Stefan?
I'm doing well.
That's good. For the benefit of future viewers of the Q&A live stream, why don't you go ahead and introduce yourself and the talk.
Hello, I'm Stefan, and you are going to watch my talk about my core reflect project, although since I couldn't really advance on that, it's not going to exactly be about that.
Before the talk starts, I'm curious, what led you to this core.reflect project in the first place?
Well, because metaprogramming is kind of expensive, and I wanted to fix that.
That's it? I mean, what were there any specific troubles you had, any specific issues that you saw this as a solution to?
Well, not exactly me. At least before Core Reflect, I didn't do so much metaprogramming because I knew how expensive it was. I did that work to elevate the troubles that Symmetry were having, because at that time I was still working for them when I started working on Core Reflect.
So this didn't come out of any of your previous work on like type functions and stuff like that?
Oh, yeah. Like the work on type functions tried to solve the same issues, but it was held back by certain problems in the compiler, and Core Reflect tried to circumvent these problems. Core Reflect tried to do the same thing that type functions were doing, which is to give you access to reflection information and to give you the ability to work with types in a certain limited fashion. And it tried to circumvent the issue that you had to introduce a type as a first class citizen. So I thought I could base it on things that already exist in the language.
WebFreak says, I'm thinking core.reflect could make a really nice and fast JSON or other serialization and deserialization. Would that be a use case?
Yeah, sure. But you could do the same thing with traits. It doesn't give you any fundamental new thing. It just integrates it better with the language, because instead of traits, you get class literals, which have all the information you query. They have them packaged up already, and you can just use it. And it has the second benefit that it's very close to how DMD looks internally, which means everybody who uses Core Reflect in any deep sense will be on the list of being able to fix compiler bugs, because they will already be familiar with the structure.
WebFreak says, could you finally work around deprecated with serialization frameworks? Work around it emitting warnings if you just check for them existing?
Not with Core Reflect, no.
They're talking about some kind of bug, I guess, which you got an issue number for that? WebFreak says he doesn't think there's going to be an issue number. It's just spewing a lot of deprecations when serializing structs with deprecated members and stuff like vibd. Oh, okay. Or with painless JSON. Okay. I thought this online compiler you've got going here for core.reflect was pretty cool. You only opened it for certain periods of time, right? Is it open? It's not open full time, right?
It's open right now. The debugging thing is not always open, because that gives you a root shell in my vServer. I want to monitor that when people are using it.
The URL is corereflect.org, yeah?
Yes, /run.
But this is basically just a fork of run.dlang.io. Is that what it is? Or?
Yes, that's what it is, with my compiler extension on it.
Yeah. How long did it take you to put this together? Not the online thing, but I mean the core.reflect. How long did it take you to get to the state it's in?
A couple of weeks. Not long.
I thought you were working on it like much longer than that. I see.
To the state that it's in right now, a couple of weeks. And then I tried to get it better. Mm-hmm. And I tried for a long time. Couldn't do it. That's where the time went.
I see.
Make it like really coherent, such that you can do things. For example, you can use Core Reflect to query the code that surrounds you, and then use that to instantiate a template, and, for example, specialize that for the application pattern that happens in the code. So you can write your own static analysis and stuff, and then use that directly to specialize your other code. But that doesn't work properly.
Ethan says he just tried his first idea, making that reflection node an enum. And his question, node returns a pointer. So this is mainly for runtime usage?
No, it's for compile-time usage, but you can only use static immutable since it's for classes. You cannot do class references with enum.
These examples you showed, I thought that was pretty cool, finding the padding in the struct. I love that concept. What other ideas would you have liked to have shown if you'd had more time to do it? Or
Well, I would have liked to show you the thing where you have a REPL interface and you just put an add REPL on a function, and then you have auto completion for that function. Like you can just tap, and then call that function and stuff.
oh, that's awesome.
Like you can take your program, you put a UDA on like the main functions that you have, and then you have a REPL interface, like just magically, which is something that I've stolen from the C++ reflection talk, actually, where they show that.
This could be something interesting for like IDEs for code completion, maybe?
If you're willing to go through the compiler, yes. I wouldn't recommend it.
What's Reiner doing with the Visual D? Isn't he using DMD as a library for that?
Yes, he is,
But he's not going through the full.
And I think he is going through the full, and I heard that it's gotten mighty slow in some circumstances. Yeah, the thing is that the compiler does a lot more than you think it would. If you just want to do code completion, there are cheaper ways to achieve that. The thing with Go, for example, where you have that, all the formatting plugins and stuff are basically calling the Go compiler, and as soon as you have an error in your code and your code doesn't compile anymore, your formatting plugin also breaks. So you can only format correct code. You can't format something that's just partially typed, and that's horrible for usage.
Ethan says he made it a static for each, I guess the example that you showed, and it errors on every line, but the pragma message works.
Yes, that's exactly the issue that I've faced. Pragma message and static for each have different priorities in their semantic ordering. We can come to that later, maybe.
Well, I guess that's a good opening for it. I don't know how many of the live stream viewers are listening to us and the talk, so I guess we might as well get into it. You encountered difficulties because of how the compiler is currently structured.
Yes.
So can you just go ahead and elaborate, please? You didn't give any details in the video. Yeah.
It's hard to give details, that's why. Thing is, static if and static assert, for example, have different priorities. So static if will always be evaluated before a static assert, if I have that right. It's very hard to have these things in your head, but I think that's true. And the problem with that is that sometimes a static if and a static assert can depend on each other in a way that makes it impossible to evaluate with a correct result. In which case, DMD will just give you an incorrect result. Like, it will not error out and say, I cannot compute this. Rather, it will assume that, oh, static assert was false. Right? You can go into a situation where the question you're asking cannot be computed at that point in time. DMD tries to wait until it can answer questions, but sometimes that waiting mechanism doesn't work. And in these cases, it's very hard to do anything about it without restructuring how things are happening.
You mentioned two causes of the problems in the compiler at different points in the video. One of the things you said was that this is how the code has evolved. This is how it has accumulated over time. This is just the state it's gotten in. And the other thing you said was that a lot of the design decisions in the compiler were made before we realized how important metaprogramming, template metaprogramming, and compile time stuff would be to the language.
Yeah, I mean, template metaprogramming works very well, actually. It works around the issues that I'm running in, where I'm trying to avoid templates for metaprogramming stuff by creating new entities. Every time you create a new entity, you can change its order. And when you don't do that and try to work on a semi-static representation where you just want to fill fields in, which is how DMD's AST works. Like DMD's AST is fairly space efficient. Right after parsing, you usually allocate almost all the fields you're going to need, and you populate them as soon as you can. However, because of that, because you start with a structure that looks like it's the full thing and it gets filled out bit by bit, it's possible for you to miss bits. For example, when you have a function with an auto return type, with an inferred return type, then certain static if conditions that act on that return type will not work if you ask them before your function is declared. Like lexically before. When you put that static if behind the function declaration in the source file, it'll work. And if it's before the declaration in the source file, it will not work. And these kinds of bugs are everywhere. You do not hit them that often, but if you do, that's a head scratcher.
So you described that pretty well, but in the video, you said that this is not going to be easily solved by people pitching in, that you're going to need some knowledgeable people, some experts to be able to sit down and hash out a solution. So why do you say that?
Because this is a fundamental issue. So essentially, this is a classic scheduling issue, which is an NP hard problem, if that says anything. It's a very hard problem to deal with. I, by myself, while I have ways to work with that, I just don't have the manpower or the time or the finances for that by myself, right? I do need to work on other things, and this is a massive issue that requires full-time attention.
But I mean, you have a general idea to how to solve the problem yourself already, yeah?
Yes.
Yeah, it's just the time and the means to do it, to make it happen.
Yeah.
So supposedly you would be a member of any group that got together to solve the problem.
I'd hope so. I think you would lose a lot of expertise if you didn't include me. I've been working on that for a long time.
Well, who else is doing as much compiler work as you are in the community?
Tim and Gare is, but I don't think he has the time.
Yeah.
And he knows the problem very well. Like, he wrote a paper on how to, or he co-authored a paper on how to tackle that problem exactly.
The way you ended the video, you said, let's create a situation where D can be the shining and progressive language that it can be. So what are the things you see that would make that happen? What are the future features like core.reflect that could allow D to be that shining, fully shining language you envision?
Seamless metaprogramming, essentially. So right now, the support for template metaprogramming in D is quite good, much better than C++, but that's not very hard. The thing is that template metaprogramming, and the C++ people do acknowledge that in the C++ reflection papers. They say we really want to be able to do that with const expr rather than with templates. And because templates don't scale, as I said before, when you create a lot of unique types, the type system is something that's meant to look at all the types you have holistically, to try and find out the common properties, to see what can convert into what, and how can these different types play together. And if you convert all your meta information into unique types, that means you suddenly have a huge number of things that have to be considered by a part of the process that has to look at everything in combination with everything else. It's fundamentally an n-squared problems to work with types, which means you really want to reduce that n if you can. And that is how I imagine proper metaprogramming would look like, where you do not work with types, but you work with regular data structures, just like core.reflect. Like you just have a struct that represents your source code.
We got a comment here in the chat box on the talk where WebFreak says he's talking about something you just mentioned about the what you would like to see with core.reflect, and he says, "Wow, that's like the next step of design by introspection."
Exactly. Yes. That's exactly one of the things that's possible. The design by introspection we have right now, the metaprogramming we have right now, it's slowly scratching the surface of what's possible, and we can go so much further, and it can be so much better. For example, you can also give custom error messages. Like right now, if you use Phobos and you try to use write-lin with the const variable or something, you get like 10 lines of error message and you have no idea what it means. And with proper metaprogramming, you can just have a filter that says, does anybody try to call write-lin with the const variable? And then you can say, sorry, you can't call write-lin with a const variable, which is much better than seeing, here are these 20 candidates for write-lin and we couldn't match any of them.
Now, I do want to get back to something you said in the talk. You did say that you were currently working on some of the issues in the compiler. So can you elaborate on the things you're working on right now?
Yes, I'm working on a generalized task system, as it seems to be all the rage these days. That means that I make every little thing that has to happen in the compiler an independent task. And if one of them can't happen because it doesn't have the information, we will just halt that. We just freeze that part. And by freezing that, we can just wait until the information becomes available. And that works remarkably well for a very early approach. Like sometimes you have to put constraints in. For example, if you just let the system run right now, sometimes your code will compile and sometimes it will not, depending on the order in which the tasks get executed. Like sometimes you try to like semantically analyze something before you have parsed it completely, and then you get garbage. And in these cases, you have to put constraints on your tasks that say you can only parse this module after you have loaded it, because otherwise you will think it's an empty module because it has no source code. Since you try to parse it before you try to load it, that can happen. And in that case, you use a so-called task barrier that makes sure that you actually read the module before you try to parse it, which is very helpful for parsing, to know what text is in it.
Are you finding it challenging to bolt this into the existing compiler?
That's okay.
Okay. No.
I have a lot of experience with DMD. That's why
see.
I can do it. I think other people would probably not be.
Yeah, I mean, because that's one of the things that a lot of people complain about when they try to add something new to the compiler. And so I was wondering.
No, I think DMD is very hackable.
Yeah, you did mention that in the talk, I believe, toward the end. But Robert Shadek had a question here. When do I get my daemon compiler as a library thing?
When my task system works. then you get that for free. And then you get it with dependency tracking. Because what this conversion of the compilation into a system of dependent task, what that means is that you know exactly what information you needed to produce something. So a template that takes a type defined in module A and a type defined in module B. You know, because you had to wait on module A and module B to come in, you know that you depend on these two things. And that means you can now cache stuff. You can cache the entire binary and only change the part that changes if you change one of the dependent modules. And if you change something that doesn't affect your program, you don't have to recompile it. And the compiler can know that.
And Ethan says task systems are life. Task systems are ultra scalable.
Yes.
Yeah.
They are awesome when they work.
And Per asks, should standard.traits ideally be rewritten to use core.reflect? And if so, should they also utilize type functions in the long term?
I think core reflect is better than type functions because there are no syntactic issues. Type functions had a lot of issues that I didn't even think about because I never went far enough in actually building them, because I was stopped before the really tricky bits would have started. And I think core reflect avoids many of these by being just a class. The thing that you get back from core reflect is just a class. It's just an AST node. There's nothing special about it.
WebFreak asks, what's your current stance on adding runtime parsing with the core.reflect API, like DMD as a library? It looks like a really nice API to have.
I'd say go ahead. It would be trivial to do that. But again, if you do that, you lose the benefit of a statically typed language a bit. So it's always
trade-off.
Yeah, generally my stance is you should allow these things for people who want to do that, because if you do not allow people to do that in a supported way, they will do it in an unsupported way. And then they file compiler bugs.
Adam has a question for Walter. Do you think you'd ever merge this stuff if it was finished? It'll be a pretty big difference.
Well, it all depends on how good it is. Yeah. Well, and so that's entirely up to Stefan. But it has to be better. It has to be better by a significant margin than what the current one is to merge it. And that's up to Stefan, and that's going to be a lot of work, no matter how you slice it.
I think it's going to be better.
All right.
But yeah, but you are right. To get the prerequisites, like having semantic be lazy and be able to pick in which order you do things, that's going to be a lot of work, and I think you know that as well.
Well, there's already been some work in that direction. The enum semantic routines are all lazy.
Yeah, and I had a look at that.
Worked out very well.
I had a look at that, and that's not flexible enough. That happens to work for enums because you do not have these crazy dependency graphs in there. I've tried to use the same approach that you used for enums, where you basically have this module.deprogress variable. That's what you're talking about, right? Where you try to make progress until there is no progress possible anymore, right?
No, the enum ones work by whenever anybody wants some information about the enum semantic routine kicks in and evaluates it.
Yeah, that works for simple enums. You can surely find cases where it won't work. That's the first step that we take, where we make it more lazy. And after that, we have to get the ability to move the order of things around so that you can have almost arbitrary dependencies between things. For example, you can say, I want to know the offset of that field and that struct. But the struct you have a template where that's a field of the struct, and it needs the offset of a field that came before it, right? That means you cannot finalize the struct without knowing that part of the layout.
Well, with the enums have values, right? And the
Yeah.
values can depend on other enum members. So how it works is it wants to find the enum value of A, and it looks at A and see that the initialization of A is based on B plus C. So then it goes and evaluates B and C. So it doesn't need to evaluate all the members. It only needs to evaluate the members that it depends on. If you want to get the offset of a struct member, what you'll need is to finalize the offsets of all the ones that precede it in the struct.
Right,
But
yeah,
the ones
right.
after it, you don't have to find the offsets of.
Exactly. That's something you cannot currently easily express in the compiler. And those are just two examples. Like that has to work for everything. All information that is semantically independent of each other has to be exposed as such, right?
Yep.
That's going to be work that has to be done. But on the flip side, you get parallelization for free once you do that, because you know the order of things and you know when things are independent of each other. So you can compute them in parallel without any synchronization issues, because they can't possibly touch each other. And that already works in my prototype, though not very well.
Yeah, it's always the last 10%. I'm relearning that with import C. It's that last couple of percent that seems to be a problem.
Yeah.
Okay, we have another question from the live stream here, and I guess this is related to the caching that you mentioned earlier, but this question is from How with the extra W's. Does that mean we can have binary patching and possibly hot reload for free?
Binary patching? No, you don't get hot reload for. Do you mean with core reflect?
Well,
it's not going to be free. You have
no.
code for it.
You were talking about earlier enhancing the compiler so that you can cache results, and I think he's trying to tie that into deployment. Looks like
you could like make a thing where you have a compilation daemon. That could work. Yes, but
sorry, it was the task compiler daemon he was talking about.
Yes, that can work. That directly work with each other, because now you have the explicit dependency graph of all the semantic stages that things have to go through. So you can see the effect of any change you do at a lexical level, and you can only recompute the parts of the semantic that you changed, that you affected, and I think that would be massively faster. That would be a light speed compiler at that point.
So would you be willing to identify potential members for a work group to work on the compiler to get it to where you want it to go?
Tim and Gare, for sure, if he wants to. It would be awesome to work together with him. Walter, of course, would be one of my first candidates to have in a compiler work group. Other than that, I'm not sure. I think maybe too many cooks would spoil the broth.
Esna says, how well would core reflect work with string mixins? And sorry, I missed that one.
It would work great. String mixins are just regular code.
Peter asks about strong types.
Very strong types. They can lift up to the heavens.
Is there anything out there that you know of in other languages that are comparable to this kind of thing?
To core reflect or to the task system?
To core reflect, not the task system. Core reflect. Sorry.
There are C++ reflection proposals that come close. Unfortunately, they're not the accepted ones. They accepted the shitty one with the template base. But there are proposals that are somewhat similar to core reflect.
Thank you, Stefan, for coming in today, for giving us the talk. Oh, hold on. We've got one question from Ali in at the last minute. The last second. How about JIT with a linked compiler?
Yes, that would work. And with a task system, it would be better because you can spin it up on 25 cores.
Do you have anything you want to say to close out the talk, Stefan?
I don't think so. I just think that it would be great if we could make some progress on a taskified or on a more granular semantic process in the compiler. If we could make that happen, that would be great. And thank you for watching my talk and asking these questions.
All right. Thanks a lot, Stefan. And now we're going to go to pick the winner. Where am I? Here we go. All right. The winner is